Okay, we're gonna, even though I already lectured on uh, chapter 18, and I think everybody was there, I'm gonna go ahead and go through it again in case you missed some points and probably correct some things that I said. Um, so I'll just try to do a quick review of what we what we covered. You have a intuitive sense of temperature, but some of what you may know may be wrong or needs correcting, and so we'll have a brief overview of chapter 18. This is the zeroth law of thermodynamics, and it's an unusual one, but it's an important one because it enables us to define temperature. We can think of temperature as the property that determines whether or not energy will transfer between two objects when they are in thermal contact. There's we've got three items here: item A, item B, and item C, which is the thermometer. It's maybe it's a thermocouple or some other type of thermometer. So the temperatures of A and B are measured to be the same by placing them in thermal contact with the thermometer object C. Now, if we place A next to B, we know that no energy will be exchanged between A and B when they are placed in thermal contact with each other. So if objects A and B are separately in thermal equilibrium with the third object C, then A and B are in thermal equilibrium with each other. If they're at the same temperature, there will be no transfer of heat energy from the hotter item to the colder item. So let's look at this quick quiz. Two objects with different sizes, masses, and temperatures are placed in thermal contact. In which direction does the energy travel? Energy travels from the larger object to the smaller object. Energy travels from the object with more mass to the one with less mass, or energy travels from the object at higher temperature to the object at lower temperature. Well, answer C, the energy travels from the object at higher temperature to the object at lower temperature. So if you just brewed some hot tea and you put ice cubes in it, it's not that the ice cubes make the tea, they're not cooling off the iced tea. That is the effect that's happening. But the energy transfer doesn't go from the cold ice cubes to the hot tea. It's the energy in the hot tea, the hot vibration or the rapid vibration of the tea molecules are transferring energy to the more stable and less active ice cubes. So energy always travels from the object at higher temperature to the object at lower temperature. And we're going to continue on in the next little lecture talking about thermometers and the Celsius temperature scale.